So we are doing 1-7. We kind of started yesterday. We started talking about proofs a little bit. And when we think about proofs, we are having this idea that you are a lawyer and you are trying to prove what you are saying. You can't just say these two things are equal because I say so. You have to give a reason why. And the great thing about math is there's always a reason why we are doing something. So first, I'm going to hit you with a ton of vocabulary. Remember I told you vocab is probably the most important thing in geometry. Without the vocab, we're pretty much useless. So first, we are going to talk about something called supplementary angles. So supplementary angles are two angles that add up to 180 degrees. So it would be like this angle over here, which is 30 degrees, this angle over here, which is 150 degrees. We would say that these two angles are supplementary because together they make 180. By the way, what is a line made up of? We've talked about this in the past. How many degrees? Yep. How many degrees in 100 and how many degrees in a line? 180. We're going to need to remember that fact for later. So, and then we have this idea of something being called complementary. Complementary angles are angles that add up to 90 degrees. And the way that I help myself remember that is I say C comes before S like 90 comes before 180. Because kids constantly get them mixed up whether they're complementary or supplementary because the words sound similar. So C comes before S and 90 comes before 180. Yes. See that again? Yep. So it'd be like if this angle over here was 40 and this angle was 50, we would call them complements because they have to be 90 degrees. So those are called complementary. They complement each other very well. Sometimes we talk about colors complementing each other. That means they go together pretty well. Numbers that go together pretty well are ones that add to 90. For 180, we call it complementary and supplementary. Does that make sense? All right, some other vocab, and I would put a star on these guys. These ones that we're doing today are really important. They're things you want to keep going over. We're going to use them all year long. So the next one we're going to go over is called the identity property. I shorten it. You can write it fully out if you want, but I call it the ID property. When you're doing your proofs, I don't mind if you shorten them up. I'm not here for spelling. Identity property. What is your ID? What is your ID? Identification, what does it do?
Tells you who you are.
Tells you who you are. It's more importantly, it can tell a cop who you are so you don't get in trouble. They're trying to find someone. You have your ID. You be like, no, that's not me. This is who I am. And this is where I like it identifies you, your locations, right? What do you think the identity property is going to do? It's going to show something who it is. Meaning like A equals A. Or probably how we're going to use it more along is AB is equal to AB. It's equal to itself. Now you're going to be like, why in the world would we ever use that? Well, later on we're going to do these things called proofs with two triangles. And in order for these two triangles to be the same, they have to have some sides that are the same. They have to have some angles that are the same. And so what we can say is, we can say that this side AB is congruent to what? AB would be congruent to what? AB. So we've already proved, you see how AB is on this triangle right here? You see how AB is on this triangle right here? So if I establish that this side right here is equal to this side, you see how I've already kind of showed that some of the sides are equal to the other sides of the other triangle? Because it's the same side. It's itself. We will do that later on. So that is called the identity property. Sounds kind of stupid right now, but it is very useful. Next, we use something called the substitution property. So I call it the sub property. There's another one we're going to call we're going to call this is the substitution property. There's another one called the subtraction property of equality. So I will write this for this one, and I'll write this for the other one. Do you see how those two are not the same? If you write this, when you meant this, what will I have to do on your paper? Mark it wrong, because this will be the substitution property, where this you meant the subtraction property of equality. You follow me? You can, for sure. You can always write the full name. If you don't want to risk it, for sure. What happens when you substitute? If you go to Wendy's and they said your meal comes with a drink and fries, or you know what? Forget Wendy's. We're gonna be more fancy like. You guys ever heard that? No one's heard that song, Fancy Like? Oh, it's a country song. Anyways, yeah, Fancy Like. So we're gonna go to Outback. But if I go to Outback and I'm ordering the, I love the, no, I don't really like that. I like their Alice Springs chicken. And if I was getting their Alice Springs chicken and I wanted to order a side, I could say, hey, I don't want the potato that you guys say it comes with. Can I substitute the potato for some broccoli, like you guys would love, right? Okay. Would they allow me to do that? Why? Because I'm substituting a what? A side for a, they're both the same value. They're both the same amount, right? Could I go, hey, you know, I really don't feel like the potato tonight. Can you go ahead and sub that out and give me a 12-ounce steak? Would they allow me to substitute the potato out for a 12-ounce steak?
That's a whole nother meal.
Why would they not allow me to do that? Those two things are not what?
They're not the same price.
They're not the same. When you do substitution property in math, we're doing something like that. You might have something, and we're going to start off easy, like x equals 3. And then I say x plus 3 equals 6. Right here, do you see where I established that x equals 3? Well, instead of writing a 3, you've done this all, you know, for your math career for a while now. You can write it as 3 plus 3 equals 6. And right here, because you took the x out and you put a 3 in its place, right there, you did what we call the substitution property. Here. Actual? I don't know. Take something else. Take something out and put something of the same equal in its place. Something like that. I don't want you to have the formal definitions. Because you know what the formal definitions do for kids? Nothing. You don't understand them. I would rather you write your own personal definition because it makes more sense. That's why I talk about Outback. Because I want you to own it. I want you to know what it truly means. And I want to make you hungry even after you ate lunch, you know?
Yeah, probably not. If it was raw bit, it would be a big mac and cheese.
I go with a baby cheese fries, what I always call them. So I get a little small portion of cheese fries, which is, at one time, was the most unhealthy food in, like, America. They did, like, a study on it, and it was one of the tops. But that's why it's so unhealthy. Cheese, bacon, potatoes. No, not this. They don't put that. They put they bake cheese that they melt over like a.
It's like just melting as soon as you.
It's good. All right. So next we have this thing called the transitive property. Transitive property. Sorry, I guess you don't want to go. Transitive property. This one is best just giving you an example. It's like this. If A equals B, and you know that B equals C, then what can you tell me? Oh, isn't that a conditional statement? Didn't we talk about those? If, thens. Yeah, see how we're going to use them constantly in this? If A equals B and B equals C, then what do you think you can tell me? Yeah, A equals C. I had a girl that had a hard time in 8th grade understanding this, and I've always used this ever since her class, because for some reason this stuck. So I was not being mean to her. We were just joking around. She understood I was joking around, so it was just all in fun. But her name was Alexis, and she could not understand the transitive property. So I said, all right, after like 20 times of explaining it to her, I said, all right, Alexis is a girl. Is that true? She's like, yes. And I said, okay, and girls are stupid. And she's like, okay. I said, then what does that mean? So if Alexis is a girl and girls are stupid, then what does that imply? Alexis is stupid. She was like, I get it. That makes sense. And then from then on, the rest of the year, whenever we would use the transitive property in a proof, I would say, what property are we using? She goes, Alexis is stupid.
I get it.
Like dead serious, she would go like, she would call that out and she'd go, transitive property. So like, I don't care what you have to use to make it make sense to you, but get something like that that will help you understand and remember this vocab. So this is called the transitive property. Now, will it always be A equaling B? Please stop. Will it always be A equaling B? And will it be B equaling C? It might be something more of like Alexis is this and this is that. Then we know this to be that as well. Okay? So it won't always look so nice and pretty as, but if you can say something like A equals B over the top of it and B equals C, then you know that A equals C. We're going to use that in just a minute. I'll show you a better example of what it's going to look like. I'm going to show you a proof today. You guys have used this property forever since you started your algebra career. This is the addition, subtraction, multiplication, division property of equality. AKA, whatever you do to one side, you have to do. That is the addition, subtraction, multiplication, or division property of equality. It just means whatever I do to one side, I have to do to the. So if I had x plus 3, or x plus 3 equals 13. Technically, what I'm doing is I'm saying, hey, you know what? If I subtract 3, what does that 3 do to this 3? It leaves me with what by itself. But if I do it to one side, since I'm in an equation, I got to keep that balance. So if I minus the 3 to this side, to be fair, I have to minus 3 the other side. That right there, that is called the subtraction property of equality. Oh. Yes. Yes. You don't always, but they will sometimes show it like this, so I'm showing you that that's how it'll be. I'm formalities I don't really care about. The concept is what I really care about. Okay? And then underneath it, they would kind of show this. X equals 10. How are you able to go from this step to this step? We would call that simplifying. Whenever you do math, whenever you combine like terms, we call that simplifying. So instead of writing it as a 13 minus 3, we can simplify that by doing the math and just call it a 10. Does that make sense? Whenever you do math, when you actually do it, we call it simplifying. Now, every one of these things that I gave you today is going to be used in a proof. It's going to be your reason why you can say what you said. So we're going to start off. Here's a proof. Yesterday, what did I teach you? Vertical angles are what? They're congruent. I said this angle right here is congruent to this angle right here. Do you remember me doing that yesterday with you? There will no longer be arc marks. You will be given, this might be a part of a picture. It might not even look as simple as this. No one is going to tell you that this is equal to this and this is equal to that. You're going to have to what? You have to know it on your own. Does that make sense? All right, but can we prove why that's true? Can we say why we know that angle, actually, we're doing this all day. Can we say why we know that angle 1 is the same as angle 2 without using vertical? Like, how? None of you question that? Why is that always true? Well, today what I'm going to show you is called the proof. I'm going to show you why we know 1 is always equal to 2. And this is your starting point for these things called proofs that we're going to do in every chapter basically from here on out. Okay, so first, what did I tell you to get in the mindset of when you were doing a proof? Who are you? When I say you're doing a proof, what kind of character are you kind of taking on? You're a lawyer, and you can't just make a statement without giving me a what? You can't give me a statement without showing like evidence of why you know that to be true. You have to know this is, yep, that is true, and I have to go, yep, that is true, and you're not lying. So number 1, what's something you can tell me up there? Nope, we can't say that. Not yet. We're trying to prove that. Not yet. We're trying to prove that. Once we prove it, we can use this later on in proofs. But right now, we're trying to prove that fact. Right now, we're trying to prove that angle 1 is congruent to angle 2. That is our goal. So we can't use that fact because it's not a fact yet. Okay, keep going. She said lines are 180 degrees. So what could you say then? Angle 1, not angle 1 and angle 2. Angle 1 and angle 3, what do they have to add up to? That is angle 1 plus angle 3 has to equal 180 degrees. Why do we know that to be true? Yeah, and for today, we're going to call them supplementary. Tomorrow I'll give you a better name for it, but for today, we'll just call them supplementary angles. It's not the best name. There will be a better name tomorrow. 2, just looking at the picture, what else do you know to be true? Kind of thinking along the same lines. Ready? What else do you know to be true? Angle 2 plus, yeah, angle 2 plus angle 3. What does that have to be? But instead of doing it like that, I'm going to do it like this. What's our reasoning why? Supplementary angles. Three. Anyone see something that I told you we were going to use in a little different way? It might not always be the same letters, but the idea is there. Why do you say transitive property? Why are you saying transitive property? Yeah, but why are you saying it up here? Because what is 1 plus 3 representing? A. What is the 180 representing? B. Do you follow me? What is the 180 representing again down here? And then what is the 2 plus 3 representing? No. C. Do I have A equals B and B equals C so far? Then what can you tell me, because I have A equaling B and B equaling C, what can you tell me? A equals, but it's not A and C, it's what? Angle. What is A represented up there as? Angle 1 plus angle 3 equals what? Angle 2 plus, very good. And what's my reasoning? The transitive property. This is your welcome to proofs. This is your first one that you're ever seeing. Is it kind of making sense to you? It's not. They're just representing. Like I told you, it's not going to be A equals B and B equals C. Then A, it's not going to be like that. It's going to be like you have angle 1 plus angle 3 equaling 180. Then you have 180 equaling 2 and 3. Well, that means that 1 and 3 must equal 2 and 3. You get what I mean by that? This is representing your A. So in the transitive, it says A equals B and B equals C. Then A equals C. You're not going to see A and B up there. You're going to see this is like your A. This is like your B. And then do you see how I have B again down here? It's 180 equaling something new. And then what did I do? I said this has to then equal that. Is that making sense? That's how the transitive property will be used. It won't be A equals B. It won't be like that. It'll be more like this right here. And we're applying it. Does that make sense? Yes or no? 4. What's our whole goal? What's our goal? Prove that 1 equals what? Do you see 1 and 2 in an equal sign? We're really close, aren't we? What's just in the way, Dylan? What's in the way of those two not just being them by themselves? Angle 3, right? But wait, is there an angle 3 on both sides? So what could I do to the angle 3? Yeah, what if I subtract the angle 3 plus angle 2 plus angle 3 minus angle 3? Do you see how I wrote the same thing here as it is here? What's the only new part? What did I put here? What's the only new part? I minus angle 3, yes? You see how this right here is the same thing here. What's the only new part? I minus angle 3. What allows me to do that? Subtraction, property of equality. Good. And what happens with the plus 3 and a plus angle 3 and a minus angle 3? What do those do to each other? And what happens with a plus 3 angle 3 and a minus angle 3? And then what am I left with? The measure of angle 1 must be equal to the measure of angle 2. What allowed me to do that actual math? What did I tell you we call that? Simplifying. Whenever I actually do the math, that is simplifying. Do you see how my final resting spot was what they asked me to prove? Do you see how that is the final thing that was down here? That's what should happen every single time I do a proof. Yes. Say that again. Because it's kind of like I have a goal. I'm trying to get angle 1 equal to angle 2. And when I looked up there, I saw that I had a 1 and a 2 almost equaling to each other. The only thing was I had an angle 3 here, and I had an angle 3, and I'm going, wait, if I minus the angle 3 from here, I can do that as long as I minus an angle 3 from over here. And when I do that, it's going to cancel this one out and cancel that one out, leaving me my 1 and 2 alone. It's up here. It's like you're actually thinking, how can I get, like you have a goal, and you're going, how can I get there? This is a really different thinking than, it's not so, okay, here's what you do next. Every time it's not the same. You kind of have to come up with your own road to get to the goal that they're asking you to do. So all these definitions that I gave you are tools you can use to try to get to that goal. And we're going to build more. That's what I call vocab. Every one of these theorems you use as your vocabulary. So now that I proved that vertical angles are true, guess what we're allowed to use in a proof from now on? If I asked you something about these angles, and I had a proof up there, guess what you're allowed to say about angle 1 and angle 2? Why? Why are 1 and 2 congruent? And you can actually use that in a proof now. Because we've proved it, you can actually now use it in a proof. So you can say angle 1 is congruent to angle 2, and your reasoning why would be vertical angles. Does that make sense? All the theorems and postulates are going to be our reasons why over here. That's why I said they're so important. Because they tell us what we do in geometry and why we can do it. Yes. Nope. In fact, when we get farther in the book, there will be someone who does a proof one way, and there will be someone who does a proof a different way. But as long as everything is logical and is true, like yes, you can say that that's true. Yes, you can say there's not one answer to a proof. There can be multiple different answers of different ways to prove something. Just like if I asked you how to go from the school to my house, is there one set way? As long as you get from the school to my house, does it matter which way you take, right or left? Now, are there faster ways? Same with proofs. There are shorter ways, there are longer ways, but as long as you get to that final destination, we don't really care how you get there. Does that make sense? Questions on that? All right, next. Some of you are like falling asleep. That's because you're not writing anything down. You want to help yourself out, you should be writing down and thinking about the things that I'm talking about. So today, this is where we're going to end. I'm not going to do this full proof out. I will start it. We'll see how far we can get, and we'll pick up there tomorrow. By the way, this is the last section that I am going over, so you will have a test very soon. This chapter, I want to take this section in particular. I want to make sure we get a good round basis on this. So I'll see how long this one takes. So I will make sure I let you know. The test is coming soon, though. Winter is coming. I don't believe it's going to be on Friday. No. No, because I only see you guys, what? Oh, I see you guys Wednesday, yeah, but my other classes, I only see them Wednesday, and they won't be ready for Friday, I don't think so. I will try to give you will for sure get a review, and we'll go over the review before you test. All right, so on this one, they're going to ask me to prove. Actually, let me write this the way they're going to write it in the book. They're going to give you a given first. Are you allowed to, what do we know about BD? What does it do to CBE? What does it do? Does it cut it in half? How do you know? Is that what we said? I'm trying to trick you. What did I tell you guys? Are you allowed to use your eyes Are you allowed to look like that looks like BD goes to the middle? Are we allowed to use our eyes? Now, what they do is they give me this. BD bisects CBE. Now what do I know about this? It bisects it, which means it cuts it what? So I know that CBD is congruent to what? CBD is congruent to what? DBE. And why do we know that fact? Because what? Yeah, that's the definition of a bisector. Do you follow me? All right. What they're going to ask us is they're going to say, prove that the measure of angle ABD is congruent to the measure of FBD. So right here, I'll highlight this for you. They're showing what they want us to prove is that ABD, that angle, does everybody see that angle? Is congruent to this angle down here. Does that make sense? All right, first, if we're starting a proof, it's called a two-column proof. On the left-hand side, what do we have? What did I write last time? This is our statement. This is what we are claiming to be true. And then what was over the other one? And this is our reason why we are making that statement. Can we make statements without having reasons? This is not your feelings because I feel like it. I don't think. No, no one cares. You are going to give us reasons. This is the one place where, you know, it's logical. It makes sense. So number one, I will give you a hint. What I always do is I always start with all of the givens that they gave me. That's normally a good way, area to start the proof. So what was the given? What is it? BD what? What is that? What is that? This up top? Is it line? Ray, right? We're going to practice that. Ray BD bisects angle what? CBE. CBE. What's our reason why? How do we know that to be true? Yep, that's our reason why. So what if they had given me like 3 different facts? What do you think I would do? I would write all the 3 givens. I would write 1, given, then 2, then given, then 3, and then given. Do you follow me? Now I'm going to look at the given and see if that tells me anything. What did we say? Because we know that this bisects, what did that tell me now? Because this bisects this big angle, what do I now know because I know it bisects it? CBD, this angle, has to be what? Congruent to what? EBD, DBE, same thing. You follow me? Because it bisects, we know that to be true. So what am I going to write for my second fact? Angle what? Angle CBD is what? Equal to angle what? What? DBE. DBE. And why do we know that to be true? That's the definition of a bisector. That is the definition of bisects. Is this vocabulary over here? Yeah. 3. Well, let's look at this. What's our goal? Is to show that this angle right here is congruent to this angle right here. Do you follow me? Well, what two angles make up ABD? What two angles make up ABD? And yes, you need to start practicing naming angles. It's not hard once you get the idea of it. What is the top one? A, B, C, and what? C, B, D. Those two angles make up the angle ABD, correct? Well, didn't I just show you that CBD is the same as EBD? Well, what two angles make up angle FBD? FBE and EBD. Don't I know this part right here, angle 1, is the same as angle 2? But wouldn't it be nice if I know that 3 was the same as 4? Because then wouldn't, if this right here is the same as this one, then isn't it a 2 arc plus a 1 arc? Wouldn't that have to equal a 2 arc plus a 1 arc? Are you following me on my logic here? You get where we're going with this? Well, how can I prove that angle 3 is the same as angle 4? Which, by the way, you can't do that. We can't draw those in there. I'm just showing you that. How would I show that those two are the same? Come on, we just proved it. How come I know this angle up here is the same as this angle down here? How come I know that those are the same? No, they're vertical angles. They're vertical. Do you see this one drawing in like that and that? And this is the top part and that's the bottom part? Do you see that over here? Just erase this kind of thing right here. Do you get what I'm saying? Yes or no? Okay. So what does that mean? Angle what? Angle ABC is congruent to angle FBE. Good. And why is that? Vertical angles. That is your reason why. Bless you. Do you follow me? Do you see how you've shown these two are the same? We will finish this proof tomorrow. There will be homework. You're going to start trying to work on these proofs.